What is this thing? It's a generator. It's a generator because we're taking kinetic energy and converting it into electrical energy. It's not a very useful or practical generator, okay, because you'd have to have two rails that go on forever, right, and keep running this thing forever. So rather than have a bar running on two rails, instead you can make it spin, or make a coil spin inside a magnetic field. And so you can do this instead. Okay, so we have here a few horseshoe magnets creating a magnetic field, and then what I'm cranking is a coil of wire. There's just lots and lots of turns of wire here. It's essentially the same thing. It's a bit more complicated because now instead of forces, you're dealing with torques and so forth, but let's just sort of sketch out what's happening. If you have let's say you have just a square coil of wire in the presence of a magnetic field. Let's say the magnetic field, now I'm kind of drawing this in perspective here, so it's going to be a little bit tough to draw. But this is the axis, and we're going to turn it in this direction. And there's a magnetic field throughout this region. Let's say it's pointing upward. So that's B. Okay. Well, let me draw this edge on because it might be a little bit easier to see what's going on there. So there's one loop of wire that is rotating in this direction in the presence of a magnetic field that is pointing up. And that magnetic field, again, could be made by a bar magnet or what have you. And at this point, we want to focus on sort of this rod, this length here, and this length here. So sort of this segment and this segment, which is moving, that segment's moving that way with some speed, and that segment's moving that way at the same speed. So let's think about, the first step is looking at a single mobile charge and figuring out the direction of the polarization, right? What's going to be the direction of the magnetic force if I have a single mobile charge moving in that direction? Out, right? Out towards us. So what happens on the front of this bar here? Well, okay, again, what was the force? It was a force on what? Imagine a single positive charge. Maybe that's easier to think about. A single positive charge moving in that direction would experience a force outward, right? So what happens to the front of the bar? Polarizes what sign? Positive. What happens to the back? Polarizes negative, okay? What's going to happen down here? It'd be the opposite direction of polarization, right? Because if you imagine, again, for simplicity, just think about a positive charge. V cross B is in, so this would become positive, this would become negative. And then you can make an analogy to a circuit once again and think about sort of two batteries in series, right? Here's the positive terminal, here's the negative terminal connected to a wire to another battery where here's the negative terminal and the back is the positive. It's the same thing. So what's going to happen in here? We're going to have a conventional current flowing in what direction? Well, it's hard to say what the direction is the way I drew it, but if I were to draw the conventional current here, would be coming into or out of the page or the board? Out, right? Because here's the positive terminal. Conventional current is going to go flow out of that terminal. I is coming out at the top, and I is going to go in at the bottom. Okay. But now we have a current, and so there's going to be a force that tries to slow the overall motion down. Essentially, there's going to be a torque on this spinning coil, and you can get that from, again, our I delta L cross R force, or cross B force, okay, where I is out, I cross B gives me a force in that direction. I is in here, so I cross B gives me a force in that direction. And notice how this force, this thing is spinning this way, but it's trying to slow it down, right? There's going to be a torque essentially in the opposite direction. So hence I have to keep cranking, or I have to have something else do the cranking for me. What else could do the cranking for me? Wind, okay, an animal, okay, we could have an animal power generator. That's certainly possible. Wind could do it, right, if we connect it to a windmill. What else? Waterfall could do it, yeah. And then you have a perpetual motion machine, right? You can get the generator to power the motor and the motor to power a generator, and you're all set for all your energy needs forever, right? You can get steam, right? You can hook up a turbine and get steam to push this, right? And you can get the steam from boiling water, and your boiling water can be heated by nuclear power or by gas or by solar or by oil or coal or what have you, right? But the idea is that we've got a way to convert mechanical energy into electrical energy. That's what a generator does, okay? So someone said a motor. What's a motor? What do you do with a motor? You convert the electrical energy into kinetic energy, right? So the simplest sort of motor, and we won't go through all the details here because it can get kind of complicated, but it's basically all based on this principle. What if let's make it, instead of a simple sliding wire generator, let's make a sliding wire motor. Instead of supplying the kinetic energy to the bar, let me instead hook up a battery. Positive, negative terminal. So I hook this battery up. And again, I still have this magnetic field pointing out. Okay? So the battery is going to drive a conventional current in this direction, right? And so it's the battery that's driving the current, but there's a current in the presence of this bar that's free to slide, and the force is going to be I cross B gives us a force in that direction. Well, okay, I don't want it to move in that direction, so I'm going to flip the direction of the battery. Plus, minus. So I'm flipping the direction of the current. Get the current to flow that way instead. And same direction of magnetic field. And so now the magnetic force on the bar is going to be what direction? It's going to be that way, right? So we're taking the chemical energy stored in the battery, converting it into kinetic energy of the bar. That's a motor, okay? And you can do the same sort of thing here with a coil, which is how motors typically operate, right? We have some current that's applied, and then you can get the torque or the magnetic forces to get the coil to spin rather than try to slow it down, and you can get kinetic energy that way, okay?